In chapter 15, question 9, it's the same type of question as chapter 8. It says, identify each of the following processes as hydrogenation, hydrolysis, or saponification, and give the products. And we saw in our discussion of the chapter 8 question that there are key molecules that will tip you off that you're either doing hydrogenation, hydrolysis, or saponification. Hydrogenation, you'll know you're doing that if you have an H2 molecule. Hydrolysis, you'll know you're doing that if you have an H2O molecule that you're adding. And saponification, you'll know you're doing that if you have sodium hydroxide or potassium hydroxide that you are adding. So here, you'd only have to worry about A. B is not applicable. So A says the reaction of corn oil, we don't know anything about corn oil, and hydrogen with a nickel catalyst. Well, there we have our giveaway, hydrogen. And because of that hydrogen, we know the process here is going to be hydrogenation. And keep in mind, hydrogenation, that's where you go from having a double bond to erasing the double bond and adding two hydrogens. You're adding hydrogen, so it's hydrogenation. And what would that happen in the context of what would that mean in the context of an oil? You'd be going from an unsaturated fatty acid to a saturated one. In other words, you'd be going from a liquid to a solid. And so by doing hydrogenation with oils, you can control how liquidy or how solid the oil is. If you're making a Snickers bar and you want the perfect creaminess, you don't want it to be a liquid dripping out of the bar, but you also don't want it to be like a hard solid that you'd break a tooth on. You can hydrogenate it to just the right amount so it's the perfect creaminess. The problem with that, of course, is the more saturated fat you have, the worse it is for your arteries. It'll build up, it'll solidify, not just outside of your arteries, but inside them as well, and that leads to atherosclerosis, hardening of the arteries, where nutrients in your arteries can't get out, waste products from your tissues can't get in, and also it builds up and tends to lead to heart attacks. Not only that, but when you hydrogenate oils, some of the cis oils in the chains will stick to the metal, and instead of reacting with the hydrogen, it'll change into a trans fatty acid. Remember, cis is when, if you draw a dotted line down the long end of the double bond, the carbons coming off it are on the same side of that, whereas trans is when you draw a dotted line down the long end of the double bond, the carbons coming off it are on opposite sides of that. So there are, when you hydrogenate these oils, some of the cis double bonds stick to the metal catalyst, in this case nickel, and they just get converted to the trans form without reacting to hydrogen. And trans fatty acids are very, very, very prone to harden on your arteries. They're even more dangerous than saturated fatty acids. So much so that if there are any trans fatty acids, the Food and Drug Administration requires by law that it's listed in the nutrition facts. So always check the nutrition facts to see if there are trans fatty acids in what you're eating. If there are, that food is definitely contributing to a buildup of plaque on your arteries. Sometimes food companies will try to get around it by making the serving size so small that the amount of trans fatty acids in each serving is too small to be listed, so they can say that there are 0 grams of trans fatty acids. But check the ingredients. If the ingredients for a fat ever says hydrogenated oil, there are trans fats in it, and by eating it, you are contributing to your own heart disease, for sure. So always look for hydrogenated oils when you eat those. Any hydrogenated oil always contains some trans fats. Right here, the reaction of corn oil with hydrogen is an example of that hydrogenation.